Welcome. Today we want to look on matrix algebra. Matrix algebra. So our first question, maybe you want to know what's a matrix. So now what's a matrix? A matrix is an array of figures arranged in rows and columns enclosed by brackets or parentheses. Generally, a matrix is represented as from A11 all the way up to AMN. These are rows and these are columns. So we want to go and look at the first entity. We want to look in matrix, and that is order of a matrix. An order of a matrix is written as M by N, where M is the number of rows and N is the number of columns. So let us now look at some of the examples. In this first example, the order of this matrix is 2 by 3 because there are 2 rows and 3 columns. In the second example, the order of this matrix is 3 by 3. There are 3 rows and 3 columns. The order of this matrix is 1 by 4 because there is 1 row and 4 columns. This one is 4 by 1. Normally, matrix of order 1 by n is called a row matrix. And a matrix of order n by 1 is called a column or vector matrix. And a matrix with equal number of rows and columns is called a square matrix. Well, after having discussed that, then let us proceed to the second entity in matrix. That is the determinant of a matrix. So we are going to look at some matrices and we will find what is the determinant. From now on, our major concern will be on square matrices. So let us start with a 2 by 2 matrix. If we have a matrix A that is represented as AB, CD, then the determinant of this matrix is written as A between vertical strokes. And so the expression for the determinant is, the determinant is given as the difference between the products of the leading diagonal and the products of the elements of the other diagonal. This one is the leading diagonal. So this is the general expression of the determinant of a 2 by 2 matrix. Let us look at an example. If our matrix A is this one, so the determinant will be 3 minus 4 by 5. That one will be 1. With this matrix as a determinant of 1. So before we proceed further, if our determinant will be 0, then A will be a singular matrix. So therefore a singular matrix is a matrix whose determinant is 0. Well, so let us now look to a 3 by 3 matrix. If our 3 by 3 matrix is represented as from A to I, so we want to see the process of finding its determinant. First of all, we need to understand the matrix of signs. In any matrix, there is the matrix of sign, which is represented as so it is represented as this. So we should bear that in mind before we proceed. Now, in determining the determinant of a 3 by 3 matrix, we identify a certain row or a column which we will use to decompose to get the determinant. For For example, if we choose our column 1 to be the one that we will use to find the determinant of this matrix, then we will present the determinant as, so this is it. You take the constant a, you multiply by the determinant of 2 by 2 matrix that is left when you assume the column and the row of this constant. So this A. Similarly, for B, we assume that column of B and that row, so we multiply B by the 2 by 2 matrix that is left, and then the same case for C. So this one is not yet over. We are now assign these constants their signs from this signs matrix. So A is positive, B is negative, and C is positive. So now what if we took our first row as the row that we will use to determine the determinant? So it will be represented as, so this is how it will be. So it will still yield the same result. So let us now to look an example. So find the determinant of A, where A is given as this one. So our determinant A, I've chosen to use my first row as the row that I would use to find the determinant. So it will be 1, which is positive. That is the determinant of 7, 6. Minus 2 times the determinant of 4, 6, 9, 3. Plus 8 times the determinant of 4, 7, 9, 5. So this is how it will be. So we will get negative 269. So the same way, if we could use our first row, let's see how it will be. So it will also give us the same value. Right, so let us move to the next entity in matrices, that is the rank of a matrix. The rank of a matrix. So what is rank of a matrix? Rank of a matrix of order m by n is the order of the largest square non-singular submatrix. It is the largest square, meaning it should be of equal number of columns and rows, non-singular. That means it is determinant should not be 0 submatrix, and it should be smaller than the original matrix. So we want to look at an example, or before an example. It means that if matrix A is a square matrix, let's say of order 3 by 3, if this is matrix A of this order, if this square matrix has a determinant which is not 0, it means that it is the rank of itself. So the rank of this matrix will be 3. We said it is the order of the largest square non-singular submatrix. But if this matrix is a square matrix and its determinant is not 0, then it is itself the rank of itself. So you may be wondering why we are saying 3. You see, the order of this matrix is 3 by 3. So the rank is 3. Well, so let us now look at an example. We're going to find the rank of this matrix. So first consideration, this matrix is a square matrix. So we want to see whether it is singular or non-singular. So let us find its determinant. So we have found out that the determinant of this matrix is 0. So this matrix is singular. So it disqualified from being its rank, because a rank has to be the rank of that matrix is a submatrix that is non-singular. So what if we take out this submatrix and find out its determinant? So we found out that there's a 2 by 2 matrix inside this matrix whose determinant is -3. So therefore we can conclude that the rank of this matrix is 2, because the order of this matrix is 2 by 2. So the rank of this matrix is 2. So these are the entities that are remaining in the matrices. That is transpose of a matrix, adjoint of a matrix, the matrix of the cofactors. We shall learn them later when we will be learning about solving systems of linear equations using the inverse method. So what to do? Please subscribe to our YouTube channel, share and comment. Just be ready in the next video. Thank you.